So next up in the series is selection and coordination of devices. Something that probably does get missed quite an awful lot unless you're right up that front end, Tim, with the consultants and they're doing the design. Maybe when it comes a little bit further down the line, you know, the product's already been selected, or if you're doing your own jobs, it's not something that's really spoken about. It's important, first and foremost.
Very important.
Very important. But also, we need to understand why we're doing this. Yeah. So we're talking about curves or time characteristic curves of devices and sort of upstream devices as well.
Yeah.
So where do you want to start with, Tim? How do we want to explain to the audience that we have this and what do they need to look out for?
I think it's important to recognise that different types of protected device, when it comes to circuit breakers, you deal with a type B, a type C and a type D. And it's a recognition that the nature of the load that's connected to that final circuit must be associated with the nature of the time current characteristic of the circuit breaker.
Okay.
So when you have a load that's non-inductive, a purely heating load, so that when it's switched on, there is no excess of current until it settles down, then a type B device is a very sensible device and it's the right device to be used for that type of load.
Okay.
The minute you've got a load that's got an inductive element, so modern lighting, control systems, motors, things like that, then suddenly you need to have a recognition that when you turn those loads on, there is an inductive spike that might cause a type B device to operate even though there's not a fault. Mm-hmm. And so you move to a type C device. And a type C device manages that better.
Mm-hmm. And then type D?
Type D is takes that further. In essence, you're not dealing with small scale motors, you're not dealing with controlled lighting circuits and the like. You're dealing with big grunty things like welding kits and heavier motors with very large induction spikes that might cause a type C device to operate even though there's no fault, but that would be appropriate at that level.
Okay, so how do we know when to select the right one then, Tim? And what I mean by that, is there any sort of times or, you know, how do we calculate the loads of the devices?
Well, the calculation of the load is the design current. That's a standard. What it's recognising, and that would just be normal under normal conditions. What has to be recognised is that the selection of the type B, C or D device, you have to know that the nature of the connected load will be inductive and the level at which you could reasonably expect that inductive spike to exist in. And therefore experience, understanding, good training, but recognising that you actually ask the question of perhaps the manufacturer, what type of inductive load is, what is this? Then you can actually select the right type of device for that.
So I've heard a term as well, inrush current. Is that what you're referring to?
That's what we're dealing with. Yeah.
So let's say, for argument's sake, we've got some lights above us here, we've got some lights in the studio. When we're switching them on, they're going 2-3 times the rating of the protected device upstream of it. So let's say the lighting, you've got a 10 amp device protecting it, but when you switch them on, the load could be 2-3 times that of 10.
And it is only for a fraction of a moment. It really isn't for very long, but it can be enough to cause a circuit breaker to trip.
We know how sensitive these MCBs are, so it does need to be for a few seconds. Yeah. So how do we understand that in line with different devices upstream then?
So when you then start saying, well, if I've got certain device upstream, and then I look at devices downstream of that, because the upstream device is protecting the cable there, it's the downstream device that's then going to be protecting the cable up to the connected load.
In a good system.
In a properly designed system. Then what you're dealing with is the nature of the inrush current, shall we say, has to be considered in the light of all of those arrangements. And recognising that requires not only a consideration of the value of current, but perhaps also the nature of time.
So would there be a time where you would have a B, C and then D type arrangement? All I'm thinking is that I know when you start creeping up to D types, the earth fault loop impedance values change drastically.
You would typically not have a situation where you would have an upstream D device for a downstream other type of device necessarily, because fundamentally a D device is very specific to a nature of a specific load. And it's also the reason why you don't mix manufacturer devices, because there's all differences between the time current characteristics depending on the nature of the manufacturer. But you do have to think about the nature of disconnection times associated with both the fault current and the time that those things will take place. And to be honest, Jake, it depends on the installation that you're looking at in a moment of time. We can't provide a general answer here and now because there isn't one, because it does depend on that load and that interaction between the various devices.
So it's not one size fits all, because you know we've both been on the tools, and you as contractors out there, you'll probably sort of generalise, and your domestic setup will be your B, and your commercial setup will be your C. You know, I was always told that, weren't you, back in the day when you was learning? That's the way it goes. Yeah. Is that sort of right and proper to assume that, or is that?
It's not an unreasonable starting point. As a starting general rule, that's not an unreasonable thing to do. What you can't then do is say that this is true always, and then you still have to look at the specific load and go, is that general principle true in this instance? And most commonly the answer will be yeah, absolutely not a problem. But then you just take the extra moment to think before you then go, and I'll have one of them.
So if you're looking for the information or the detail around the time characteristic curves of our particular devices, you can get them on Amtech or Trimble, and you can get them on Electrical OM. So if you are looking at clear design, you can go onto either one of those systems. Our information is on there, and we can provide you with all of that as well. So that was just a quick snapshot into time characteristic curves. We'll probably do a more in-depth one, and we'll probably run up a separate screen for that. But stay tuned for the rest of the series, and we'll see you on the next one.